Morning, good afternoon, everyone. This is Diane Fodell. Thank you for joining the Cognitive Systems Institute Speaker Series today. I'm happy to introduce a friend and a colleague from IBM Germany, Gerhard Satzger. He's the director of the Karlsruhe Service Research Institute, an industry on-campus initiative of IBM focused on innovation in IT-based services. He's also a professor at the Karlsruhe Institute of Technology. His research interest is in the transformation of enterprises based on digital services. This includes topics like service innovation, service design, service analytics, and the collaboration in service systems. Before joining Karlsruhe Service Research Institute, Gerhard spent many years in industry in various national and international leadership positions within IBM. Joining Gerhard today are Sebastian Hirschl and Kathrin Fitzer. Both are graduates of IBM's dual academic program, where students split their time between university and IBM. Working at the university and working at IBM. They graduated from Karlsruhe Institute of Technology last year with a master's degree in service management and engineering. Sebastian is working as a strategy and analytics consultant, Kathrin as a cognitive computing consultant. Both work for IBM and are working with clients in the insurance industry. Welcome, Gerhard, Sebastian, and Kathrin. Today they will take us through their experiences joining industry and students for cognitive solutions at Karlsruhe Service Research Industry. Thank you, and I'll turn the call over to you.
Super, Dan. Thanks very much. So this is Gerhard. So what we want to do today is not just take you through a number of cool projects related to cognitive technology, but also talk a little bit about how we can include students to early adopt those technologies and to drive innovation together with industry. The reason for us doing this is just to share maybe two, organizational setups that we have, particularly here in Germany or in Karlsruhe. The first one is that in Germany we have a system that kind of has institutionalized a dual education. So either if you do an apprenticeship, you have the option to do this in a dual role and share your time between employment and the school or you're educated in. And when you do a bachelor's, you have options to do this in a dual scheme, sharing your time between work and university. And you can also do this on a master's level. That's what Sebastian and Kathrin did. As IBM offers a particular program which is called Master at IBM, which allows you to continue work, but at the same time get your master's. So that's kind of a dual thing that helps to keep students in touch with industry at an early age. The second thing in that perspective, which is interesting, is the industry on campus construct, which Diane already alluded to, that we run here in Karlsruhe, that we have a group of industry folks that run research groups here on campus at the university. And if I can just move this forward by one, is what you see there is a construct that we run here at the KIT, the Karlsruhe Institute of Technology, one of the, I would say, most renowned universities in Germany, where we bring together a number of people that are dedicated to driving innovation in digital services. And we have two groups in that are not just paid for, but also staffed by industry members. So my group, myself from IBM, and then another group from Bosch. And then we have 5 groups that are contributed by the KIT. And all of us share the conviction that interdisciplinary work is important. So we have people from computer science, from economics, from production and engineering, all working together to really drive innovation across those disciplines. Because we're convinced that crossing those boundaries is something that will get us forward even more than just digging deeper in one of those disciplines. And what we've constructed in the meantime is, I'll just move the forward here. And what we've constructed in the meantime is an education program which allows students within their different master programs in computer science or industrial engineering to focus on digital services. And what you see on that chart is a number of modules that students can take and which we use to tailor individual job profiles or support for individual job profiles. So if you want to become a data scientist, we would recommend certain of those modules to be combined. If you want to become an IT service manager, we would recommend other modules to be combined to really drive this job profile. And along that, curriculum, we enable a number of options to get students in touch with industry. At another point in time, I think we used that type of call to introduce a design thinking program which we run in cooperation with industry, where students solve industrial innovation challenges with a design thinking methodology. What we today will showcase is, three projects. One is a student class where we use Watson technology. The other two will be projects that were done in master thesis, which will be presented by Sebastian and Kathrin, where we use the master phase in the education to really do some hands-on work with industry, but not just do hands-on work, but do this with the right methodology in the background, and really using academic and scientific methodologies to solve real-world problems. And with that, I just want to go to the first example that I want to share, and this is an example that where we, as the KIT, try to use the latest cognitive technologies and incorporate them in class. And in last year, we were one of the first universities in Europe that actually used Watson technologies for student work. And one of the events that we created was a seminar where students would work on projects using cognitive technologies. And the projects were kind of handpicked themselves, and they picked projects that were not necessarily business related on the first sight, but were also things that were kind of, just cool things to look for. So one of the examples was that students ran or developed a Watson Game of Thrones expert, where you could ask questions on the TV series. So, for example, who married whom at what time and stuff like that, where they would rely on a lot of information that they would be able to extract from on the storyboard of those many, many series that there were. Another example was that one team dedicated their work towards the U.S. medical licensing exam, where part of that exam is that you have to take or pass a multiple choice test, and you have to get to like a 60% level to pass that part of the license exam. And the students within one semester even got it to 50%, just relying on a lot of information that was there in unstructured form that they fed into the system as the corpus of knowledge, and then applied Watson APIs to do that. On the top right-hand side, you see students that actually brought these projects to the CeBIT fair on the IBM stand. The CeBIT is one of the largest IT fairs in Europe, probably the largest. Just happened in March this year as well. And what we did as IBM, we brought 3 student teams from 3 top universities to the IBM booth, and they had their own stands, and they were attracting clients and talked about cognitive technologies with their fun projects that they did, which I think was a great success, not just for the audience, but also for the students themselves. So that's a format that we've been using and trying to get students in touch with new technologies. The other thing is that we use the master thesis as an example to get students in touch with industry, with the one big restriction that we drive students to apply solid academic methodologies to do their work. And with that, with a combination of practical context and solid academic background, I think we're able to really come up with really cute solutions. And we'll see two of them, which are being presented by Sebastian and Kathrin. Both of them were created within this Master at IBM program. And this program sees, as I said before, students work at IBM, but then at the same time do part-time work at the university. And the culmination of that part-time work is the master thesis, which is done in cooperation with the industry. And in that particular case, in both cases, we were able to really leverage the industry context that the two already had to instill this academic knowledge and instill the new technologies. And I would just ask Sebastian to start with his example, which is both are out of the insurance industry, one out of the car insurance industry that Sebastian will start with, and then we'll continue with Kathrin and the healthcare industry. Sebastian, would you want to go ahead?
Thank you, Gerhard. Thank you. Right, this is Sebastian. Let me give you a quick overview of my project, of my master's project. I will start with the situation many insurers in Germany and also outside of Germany are in right now. So many of those insurers employ classic descriptive analytics to determine reserves. And for those of you who don't know what a reserve is, it's just an estimation of the overall payments expected for all claims in 1 year. So the insurance company knows what kind of money they need to reserve in order to pay all of those claims the customers get in contact with. So many of those insurers are using classic descriptive analytics, as I just pointed out, to determine the actual amount of those reserves. And right now, there are many movements towards new requirements by regulatory institutions who force pretty much force the companies to install a transparent and also more transparent and a single claim reservation technique. So this means the reservation process as a whole needs to be more transparent, and it also needs to determine a reserve based on a single claim and not an aggregated format which they are employing at the moment. So the key task in my project was to determine those reserves on a claim level. So pretty much estimate all of the payments which are associated with one claim throughout its life cycle. And second question I want to answer is, how did I do that? So I used a quite good data set from a large insurance company in Germany, actually, a quite well-known insurer for car insurance in Germany. And I did my work on 3.6 million claims, which actually happened between 2011 and 2016. And with those claims, I then modeled a predictive analytics model, and to actually determine the amount based on some input variables I evaluated based on their influence to the overall amount. So, Gerhard, if you can move the slides one forward, please. Thank you. With this model in place and some general linear models to determine the actual amount of the claim, what are the results of those of this model? And you can see that in the chart on the left side of the slide. The blue line being the estimation from, or the prediction from my model, and the red line being the estimation from the classic descriptive model. And with that chart, you can actually see that that the blue line is pretty much or is closer to the zero x-axis in this chart, and the red one is further away from this axis. And this means that on the x-axis you can see the quantiles over the whole test data set, and on the y-axis you can see the overall deviation from the actual value, which is brought by the test data set. And if you put it on a simpler figure, the average absolute deviation is at 38.1% from my regarding my model. And if you employ the old model, you get an average deviation of 60%. And this means that the descriptive analytics model is cannot be as accurate as the predictive analytics model I'm leveraging for this estimation. And you might be asking yourself, how can I put that into a cognitive system? And for that, I want to just quickly talk about future use cases for this model. And on the right-hand side, you see a small figure which I wanted to use to actually illustrate that. And so you can actually put that model I developed into a Watson system and let a possible customer talk to Watson when he actually has an accident or something like that, or just wants to report a claim. And Watson then can actually ask the right questions, so the model can determine the overall claim amount of this specific claim. And therefore, the whole claim reporting process can be automated, or even or at least the case handlers, which are typically handling those cases, can be aided with a model like that. And many insurance companies in Germany are right now trying to find a way where they can have something like this, what I call a cognitive assistant, which automatically handles those claims and drives productivity in the insurance companies. And with that, I can hand over to you, Kathrin.
And before you do this,
yeah.
this is Gerhard. Just one more comment. I think Sebastian did this work for one particular car insurance company in Germany, but the application potential of that solution is, of course, huge, right? Because you just think of how many cars are insured across the globe, and I think almost everybody has the same type of data that comes in for the analytics part, right? When there's a damage, that's kind of always the same type of data that can be used then to come up with the appropriate reserve. And the same applies, of course, to the theoretical extension to the communication with a Watson type system. So I think it's a small project which has a lot of application potential. Okay, with that, I just want to transfer this over to Kathrin, and there's a chart as well.
Okay, thank you, Gerhard, and also thank you, Sebastian. So, as it was already mentioned in the beginning, I did my master project in the health insurance industry. And I first want to give you an overview about the situation that I found there. So I worked with an IBM client in Germany, which is a huge insurance company, and they receive high volumes of unstructured data every day. So they receive customer letters, they receive bills and invoices which customers want to have reimbursed for their purposes. And this insurance company also receives a lot of medical records because it offers health insurances and people give their medical bills and reports there. And then the insurance provider has to deal with these reports. And as of today, all this processing is done manually by subject matter experts who read through the documents, interpret it, and make decisions based on it. And these processing by SMEs is very time consuming and of course costly, because they must have the skills to understand these medical records. The characteristics of medical records are that they usually contain like special technical language, medical codes, abbreviation, Latin terms, so it's not so easy to understand and read for everybody. The goal of my master's project was to accelerate the decision making by SMEs by means of Watson system supporting the SMEs. So the goal in the first place was not to replace SMEs by the Watson system, but to help them make quicker and better decisions. So what was the approach? How did I do that? On the right hand of my slide, you see like the raw medical documents. And today, SMEs read through all these documents. And what we wanted to do is to implement an information extraction system by Watson, so that he finds and classifies important information in the documents, which are then highlighted. I hope you can see the colors on the right-hand side of the slide, so that the SME finds the right information and can make his decision. The information extraction I implemented in two different ways for two different kinds of medical records. Firstly, psychological reports. I used the rule-based approach for this. And secondly, I had a look at surgery reports, and I used the machine learning based approach for this. Both approaches were based on Watson technology. And let's talk about the results and what I learned in this project. So I gained or I evaluated F-scores of like 50 to 60% for my information extraction problem, which is a good beginning, but not mature enough yet. So a target value for this F-score would be like 80%. That means that the cognitive information extraction system is not ready for production yet, but it already could provide some good value. I also learned that the two different approaches, rule-based and machine learning-based, very different advantages and disadvantages. So the rule-based approach is very, very powerful and very precise, but very expensive to develop, as all the rules and dictionaries have to be stated explicitly. And the machine learning-based approach provides much more quicker results, but I use an API for this, and the customization possibilities are limited there. So, the learning is that the cognitive technologies can provide a value for this natural language processing and information extraction for a specific case, like medical records in my case. But it's important to choose the right approach and the right tool to do this. That was an overview of my project, and I see that we have 5 minutes left now. So I think that would be the time to ask whether you have any questions regarding all our projects and presentations.
Thank you so much, Gerhard, Sebastian, and Kathrin. Audience, please unmute your line by pressing *1 to ask a question. Are you having trouble unmuting? While go ahead.
This is Scott McLeod in the San Francisco Bay Area. Thank you for your very edifying presentations. I'm curious if you can perhaps step back a level and say what Watson adds to basic SQL querying and data analytics, and perhaps how you would engage that process maybe differently in your master's theses with Watson than compared to SQL, using SQL querying approaches in data analytics, please.
Kathrin, we want to answer this from a master thesis perspective?
Yeah, so I think in my case, the difference is that I'm dealing with natural language text here, which is free text. It's not structured, so it's not contained in any SQL database. And the key advantage of these cognitive technologies that I used is that they could understand these natural language and interpret it, and not only do some pattern matching and keyword search, but really to understand the context of the documents and there to find the right information there.
Yeah, and I may add on the projects that we had with the student seminars that increasingly we're able to use a very differentiated set of Watson APIs that are made available as a service on the IBM Bluemix platform, where you could say, if I have specific tasks to be handled by a cognitive system which is able to either understand spoken language, which is able to recognize facial expressions, which is able to understand or evaluate unstructured data like text, etc., you can tie that into whatever application you're developing. So we're, I think, on the verge of getting a really flexible support of cognitive functions, which are made available on the cloud, for example. So I'm not sure how far you are into that, but there's one nice application which is called Personality Insights, for example, where you just input a text and it will develop or it will estimate certain personal characteristics of the author, like the degree of extrovertedness or stuff like that. And you can just use that functionality to learn more about the authors of text, for example, your clients that have put in a complaint or a report or whatever, and you will learn about that by just being able to apply predefined cognitive functionalities.
Great, thank you. I may have a follow-up question about multiple languages, and I may follow up in email. Thank you very much.
Super, thank you.
Thanks, Scott. Are there other questions? Well, Gerhard and Sebastian and Kathrin, I think your education model in Germany is so appropriate and valuable that graduates can join the workforce already experienced in working at a company like IBM. So we're very lucky to have you, Sebastian and Kathrin, in IBM. And Gerhard, thanks for your leadership on this whole program. We're about out of time, so if there's other questions, I'll ask you to ask them on the LinkedIn discussion group. And audience, thank you for attending. Gerhard, Sebastian, and Kathrin, thank you for presenting, and we'll see you all next week.
Super. Thank you very much. Have a good day.
Thank you. Bye-bye.
Thanks a lot.
Bye, everyone.